Good morning all. Today I'm going to build my version of this, which is a little CH340 USB to serial converter. And I'm going to do it using JLC PCB's SMT assembly service. And to make it a challenge, I'm going to use only basic parts. Now the CH340G is a basic part. I found a 12 megahertz crystal. It's a square one. It's in a little square, rectangular package. Surface mount, of course. That's a basic part. Can't find a polyfuse in basic parts, so I'm not going to bother with it. I'll be able to find capacitors and resistors. That's no problem. This diode, I'm not sure what it does. It looks like the cathode is pointing to positive, so I've got a funny feeling it's a Zener possibly, or just a diode that's sitting across 5 volts. No, that wouldn't do anything, would it? No, it's got to be a Zener. Yes, it's got to be a Zener. I need a couple of 22 puff load capacitors for the crystal. 100N, I think, goes on the 3.3 volts of this. I'm going to have some LEDs. There's nothing on the back of this board, incidentally. Oh, breakouts. I'm going to break out ground, VCC 5 volts. Not going to bother with the 3.3 volt input. TX, RX. I think it's DTR, data terminal ready, and RTS ready to send, because I believe both of those can be used as reset signals for the Pro Mini, which will sit here, this is sitting next to. For my USB connector, I think I'm going to go for the Mini B with through hole pins. Now it appears that you can have SMT assembly on SMD assembly, SMT I think they call it, don't they, on a red PCB. So I'm going to go for a red PCB, and I'm going to call this one Chorizo. Chorizo, using the CH of the CH340 and the 0 on the end. That's what I'm going to call it. So here I am in EasyEDA. I've got my CH340G here. I've got my USB connector here, 12 megahertz crystal here, and a couple of 22 puff capacitors. So let's go about finding out how I found these items. So if we hit the library, right, well, I'll start with the 22 puff capacitors. I simply typed in 22 PF, and there are 3 basic parts here. We've got an 0402, 0805, 0603. Maybe I'll be brave and use an 0603 this time, so perhaps I'll use that part. For the CH340, I simply typed CH340. And the basic part is at the top there. It's the CH340G, so that's the part I used. For my USB connector, I typed USB Mini TH, and it's an extended part, this one. It's a Mini USB B 5-pin female through hole C46398. So I'll place it, but when I come to order the board, I'll specify that it should not be fitted. It's not a surface mount part anyway. And for the 12 megahertz crystal, I think I simply typed 12 MHZ. Let's try that. And even without pressing the more button, and I'll go to the bottom to show you that there is a more button, there it is. Even without clicking that, here is an oscillator, surface mount, 4-pin, length and width parameters there, 12 megahertz, and it's the YXC one. If I click on it, oh, I think it was showing anyway, but there's the schematic, there's the footprint, and there's a photograph of the little rectangular crystal. So let's start wiring it up. I'll use the wiring tool to go from D- on the USB connector to D- on the CH340, D+, oh, that goes straight across. And I'm going to use net flags for VCCs, so I'll use the 5 volt one. We'll put a VCC there. There's another one there. I'll use the ground one. There's a ground there on the USB. I'll need a ground between my 22 puff capacitors. Let's wire those up. So let's do the crystal now. Back to the wiring tool. One side of it will go to X in. like so. The other side of it will come across here to X out. We're going to wire that to the two 22 puff capacitors like so. Now these two pads here, 4 and 2, are marked on the datasheet as ground, so I think I'll ground them. I'll wire them, why not? So let's bring that over to here, wire that to ground, and similarly to pin 2, wire that to ground. That should work. Now I need to bring TX and RX out to a connector over here. Now that's going to have VCC, ground, TX, RX, RTS and DTR, I believe, are the signals I need. So that's going to be a 6-pin. So I'll go to the regular EE library and scroll down to single row header. I'll go for female, even though I'll probably put male pins in it. The female footprint has smaller holes. I like it. It's a tighter fit. 1x6. Oh, I need to click it and place it. And that's my output connector. So this connector, let's wire that up. I think I'll have VCC at the top, ground at the bottom, but I might put that on pin 2. I quite like having VCC and ground next to each other. Then we'll go for TX and RX, and then we'll go for the 2 control signals, which are only used as reset for the Arduino Pro Mini, so that it installs the program properly. Okay, I'll wire those up. And just because it's hard to trace these wires, I'm going to put some net labels on here. And I don't really need to bother with 5 volts and ground because they're close by. But this one, number or pin 3 on my connector is, oh, what was it? I can't even remember. That's TX. I'll put a net label on these 4, I think. So this one is TX. TX. That means this one has to be RX, but I will check it. Net label 3 is, that's DTR. That's, I think, the one normally used as a reset. So DTR, and the bottom one will be RTS. RTS. That just helps me remember what's connected to what. So what remains? V3, the 3.3 volt or possibly 3 volt input, needs a 100N to ground, so I've got to find a 100N capacitor. I was just wondering actually whether I might just go for the EE library and put a basic capacitor in there and then specify it later. Let's do that. I prefer this capacitor, the US symbol, so let's put that in. I'll rotate it and put it down here somewhere. That's going to be tricky, but anyway, let's place it there. I'll put in the 100N now. I just want to see how difficult it is to assign a library component to that after I've placed it, because it's much easier to pick out of this EE lib than go wading through the main library. We need a capacitor which will be, and I prefer this symbol for the electrolytic, or tantalum probably in this case. Are there any tantalums in here? Yeah, tan SMD, A, EU. Well, let's go for that one and place that up here. I'll exit to flip it so that the pos and neg are the right way around. I don't know, let's go for 10 mic there. I don't think it really matters. I'll put an F on there as well. And again, I'll assign that later. I think that's probably, I might put 100N next to that as well. I'll have a think about it. I don't believe there's anything else I need. I'll just double check. Well, the only other thing that's on that little board I showed at the beginning are LEDs. So let's put a couple of LEDs in. I prefer this resistor symbol, the US symbol. What have we got in there? Well, I'll put in 0603s, why not? They can always be changed later. So I'll put 2 in here. They'll need to go a bit higher actually, I think. And the LEDs under here. Now, on that little board they had the LEDs being pulled down by the TX and RX lines, and that's probably because they have a better pull down drive than pull up drive. If I move this 5 volts up a bit, I can probably link that across to these resistors like that. 1K, yeah, 1K is probably okay. I think that there are 102s on that board I looked at. Let's get a couple of light emitting diodes. LED, well, let's have 0603. Now, shall I worry about red and green? I suppose I could. Let's have a red one for this one. Rotate that downwards. And let's, oh, the label's a bit huge there. I'll just move that stuff around a bit. Right, I'm pretty sure that that's everything I need. Now, I just wanted to check this crystal. So I'm going to do a right click, view datasheet. That takes me to lcsc.com, and it's a Yangzing Tech. This thing here, that's a photo of it up there. Little surface mount 12 megahertz crystal. Because I'm just thinking, does it have the capacitors built in, or do you have to put them in externally? So here's the datasheet. Oh, there's not much there, just 2 pages. What's it say? Load capacitance 10 puff, 20 puff, or specify. It's not immediately obvious to me. Here are the markings: ground for pin 4, ground for pin 2. 1 and 3 are either side of the crystal itself. But does that mean it has load capacitance built in? Or perhaps you can order it with load capacitance built in. I mean, it probably won't matter if I put 20 PF or 22 PF externally as well. It'll probably still run. But I just can't work out from this datasheet whether the load capacitance is actually built in to this device. So I'm none the wiser, really. And the other thing I wanted to do was just take a look at this USB connector. So again, I'm going to view the datasheet for that. And that also takes me to lcsc.com. There's a photograph of it, and you can see it's got 4 mounting pins and 5 through-hole connector pins. So that's definitely the device I want. I'm going to ask them not to fit it. I have seen them on eBay, so I'll buy in a few of those and do that component myself. So I think we're ready to go. I'll save my file, otherwise it won't produce a PCB. Let's do a convert schematic to PCB. There are some unfinished nets. Now, can't remember who said it, but you can put markers on this little X here. You can put it on the unfinished nets. I wonder if you can put it directly on those, actually. Like so. And that should stop it complaining about unfinished nets. There's one there as well. Yeah, let's see if that makes any difference. I'll save that and do another convert to PCB. Oh, yes. There are now no unfinished nets. Handy tool. Oh, no. It's still saying there are some unfinished nets. I'll try and find them. Yes, I found the unfinished nets. They're on sheet 2, because I left all my other Arduino stuff on sheet 2. So I think actually I'm just going to delete all of that stuff, because I was hoping that working on one sheet wouldn't bring the other sheet in, but that's not the case. So back to sheet 1, do a final save. Oh, it is saved. Convert to PCB. And we've got a PCB. Excellent. So here's the printed circuit board layout that I'm going to work on. Now I want to work in mils, but actually I can see a bigger problem which I need to sort out, and that is that capacitors C8 and C6 are massive through-hole versions. So I need to go back to the schematic and alter those and then update the PCB. Right, I'm going to work on this printed circuit board, probably mostly off camera. That'll go that way around. I can probably have that sticking over the edge of the board. just to get roughly everything in position, and then I'll come back and we'll have a look at the selecting of components. Those two components are now C1 and C2, both 100N. This thing is going to go up here somewhere, and there's my crystal, and that's going to sit up that end of the CH340 because it connects to these two pins up here. So I'll get all these other components on my board, get my board sized correctly, and then I'll come back and we'll specify components for the capacitors, resistors. Oh, they're quite big, those resistors. I think they were 0603s. Actually, I can't remember. Yes, they are 0603 US. So I'll do that and then I'll come back. So an hour or two later, and I've got my board. I've called it Juliano Chorizo. I think I might change that Chorizo to Chorizo V1 because it's highly likely to change. Oh, that doesn't fit anymore. I'll slightly reduce the text size on that. Right. Okay, that's better. So here's my USB mini B through hole connector, CH340 here. Now the resistors are 0603s, and that's because I picked 0603 here in my resistor selection. The LEDs, well, let's do the capacitors first. They're also 0603, apart from this one up here, which is a tantalum SMD-A. So I've got to make sure I pick the right one when I specify the components. The LEDs are also 0603. I chose a red and a green, but I've got to find those, of course, when I pick my components. So I'm going to save this now. I think, oh, the other thing, I didn't ground the metalwork of the USB connector. I did a quick search for whether you should. Some people said yes, some people said no, some people said put a resistor capacitor network on it. I'm just going to leave it unconnected. Let's hope it works. The other thing is I've put ground planes top and bottom. Various people were saying do that so that you don't etch away unnecessary copper. So that's my top ground plane, and there's my bottom ground plane. So I'll just make those invisible so we can see everything else. Go back to the top layer so that we can see the silk screen nice and clearly. Now the other thing I might need is some labels on this connector for, because I can see the labels here, 5V ground, TX, RX, DTR and RTS. It'd probably be better if I had those on the silk screen, so I'll do that now. And so I think I'm ready to make Gerbers. So let's press the G button here. And it has incompleted connections. Do you want to check the connections? I think those are just going to be these rat lines here for the USB. Oh, it says USB 3_0. So yes, that's all it is. I'm happy to leave that. So let's try G again. No, keep going. And we should go to the place where I can order my board. Oh, that looks quite nice. Yes, I've already got my coupon, so I can't do that again. Well, I don't suppose I can. So it's a 2-layer board, quantity 5, 1.6 thickness. I'm going to go with red so that it matches my chorizo idea. Hassle with lead, 1 ounce copper. So that's $4, not including the PCB assembly. Let's click order at JLC PCB. Let's check all this. Those are my Gerber views. It's 2 layers. That's the size. 5 boards. Single PCB. Red I want. Hassle with lead. 1 ounce. No gold fingers. Don't confirm the production file. Fully test. I'm not sure what that means. Not sure how they test it. No castellated holes. Don't bother ordering the removing the order number. I'm happy with that. Down to SMT assembly. Now it says choose the accepted side, so I want parts put on the top. The parts that are not in the PCB SMT parts library won't be placed on your board, fine. And you can't have V-cuts with SMT assembly, but I'm not doing panelization here. Tooling holes added by JLC PCB, confirm. Let's see where that takes me. And that takes me here where I have to add the BOM file and the CPL file. So now I think I need to go back to the design and check that my parts are all the correct size to fit on the footprints. So back on my PCB, I'm going to click BOM, and that shows all the parts I've selected. Now the 200 ends don't have a part number. 10 mic tantalum case type A doesn't have a part number, 32 by 16. This is the header, that's not going to be included, so I'll take that out later. R1 and R2 are 0805s. Oh, that's interesting. I thought I picked 0603s. Well, 0805s are fine. And these three, I've selected parts for those. The mini USB, again, I'm going to deselect it for SMT assembly later on. Now, if you click assign LCSC part number, so these are for the 200 ends, we're just sent straight back to the library. So I can find some items in here and then assign those. Let's give that a try. So that's putting in 100NF has brought me to this. This is a basic part, 0603, so I think I can select that, assign. Good, that's got an assigned part. Let's do the tantalum. Now, I'm not sure how I'm going to find this one. Let's go into capacitors. Tantalum, which is here, and see if I can find a case A 32 by 16 and a basic part. That's not, that might be tantalum, that's TA. If I click it, will I get to see it? Oh yes, that's tantalum, the little yellow thing there. 10 microfarads, 106. It's 3.2 by 1.6, so I assume that's the case A 3216. I suppose I could look at the data sheet for that. Can I do that? Yeah, view data sheet. Tantalum capacitors. Oh yeah, case A 3216. That looks like the part I want. So the header I'm not having fitted. All that's left are the two 0805 resistors. Did I really pick 0805? I think I might have done. Okay, let's assign a part to that. So they're 1K. Let's find a suitable 1K resistor. So I scrolled down and I hit the More button a couple of times, and I found this. It's an R0805, 1K, 1% resistor, 1001. That I think will do. I'll click that and assign it. And that should be all the parts done. Everything except the header, which I'm not having fitted in any case. So that's all done. That's all the BOM parts. So I will export the BOM. That goes into my downloads folder. The next thing I need to do, I'll close that, is to create the pick and place file. I don't need to mirror the coordinates, so we'll just export that. That's easy. And now I can go back to my order page, which was here, I believe, and add those two files in. So those two files are uploaded. Let's hit next. My BOM and my pick and place files are in. And now I can decide whether I want these items put in or not. Well, I don't want the mini USB put on the board. I don't want the header. I do want the red LED. LED2 green is down there. I think I want everything else. I want the 1K resistors, 22 puff capacitors, 10 microfarad tantalum, 12 megahertz oscillator crystal, I assume. I hope this works. CH340G and a couple of 100N capacitors. Awesome. Next. Oh, and it's in red, and it should overlay my components. Oh, that's looking a bit wrong. We've got an orientation problem with U2. Why has that happened? Also, I've got resistors where capacitors go. Oh, maybe not. Maybe it just shows it like that. Well, there's some sort of issue here. I'm going to have to try and solve it. Well, it does say here, the parts placement is for reference purposes only. Our engineer will review and fix the component's orientation in 4 to 6 hours after you place the order. You can check the result in your order history. Shall I just rely on that? I think I will for this. I'll rely on them rotating this CH340 and putting it in the right place. So I think I'm going to go for it, which means save to cart. So there it is in my cart. The orientation still shows wrong on there, but we hope they're going to fix it. So $2 for the 5 boards. Parts assembly $19.89. Of course, there are 5 of these boards. That's a subtotal of $21.89. I'm going to have to add shipping to that. But I'm going to go ahead and order that, and we'll see what it looks like when it turns up in a box. But for now, cheerio.